we discuss aerodo problem, chapter 1, question number 3. Cars start moving rectilinearly, first with acceleration, it is given. Initial velocity is equal to 0 because the question asker is saying that cars start from rest, then uniformly and finally decelerate at the same rate, come to stop at the total time of motion equal to, it is also given, and the average velocity during that time is equal to this, the average velocity per hour. This is kilometer per hour. How long does the car move uniformly? This initial velocity is also given, final velocity also given, both are 0. In first case, it is accelerating, and in the second case, moving with constant velocity, and the last retarding with same magnitude as accelerating in the first case. Here already solved because this is the case when this is the first case in which suppose car is accelerated in this zone, and in this zone moving with constant velocity, and the last zone it is moving with retarding. Now acceleration, the x component of acceleration is taken as this. In this case, acceleration will be 0, and it is minus of x because retarding case, so direction of acceleration is opposite of the acceleration. So here the time interval taken in first case is delta ta or ta accelerated. This is moving with constant. This is retarding. We use this formula because the particle is under constant acceleration, and it is applicable only when particle is moving constant acceleration. This is the change in x, final x minus initial x. This is the initial velocity, x component of initial velocity, and so on. This is the final velocity. This is the initial velocity. This is the x component of an acceleration. This is the time interval in which the velocity become vi to vf. Now in the first case, if acceleration x is taken plus omega, this is an acceleration w. This is the initial x component of velocity, which is taken at 0 because car is moving from rest, and this is the time interval. This is the delta xa. For a subscript is used for accelerated motion. Ax is taken as this delta t. Delta t, this is t square. So first 1a. This is for the velocity, final velocity. Suppose for simplicity, this is v and t. Similarly, in the second case, acceleration, because moving with constant velocity, so this will be 0. The initial velocity and the final velocity, that is in this interval. Here is the initial velocity for this case, and here is the final velocity because moving with constant velocity. So here velocity and here velocity are same. And time taken is tc, means constant acceleration. This is the relation. Here the third case, minus of this because acceleration is here negative. This is TR for retarding. And similarly for velocity, the F, because finally a car stops, here stops, so this will be 0, and V for the initial velocity is same as the final velocity of second case, so this is V, and so because from here this equation and from this equation T equal to TR, चलिए delta x t is first equation is taken in the form this because delta t is replaced with capital T. This is, and the third, because total time is given top the TA, TC and TR, accelerated motion, constant velocity, and this is retarding case. Because T equal to TR, so and this will be capital T, so this is the relation. Now given the average velocity xf minus xi, this is divided by tf minus ti. This is the xf, here is the xi. This is x. Sum of this will be putting all this value. This is the difference which is equal to 0. This is common, taken common. V. This is TC and T. Now we substitute T, the value of T from here, and this is TC plus T minus TC half, and putting the value of V from here. So after calculating, this is well, because average velocity is given, and we have to find the actually time in which particle is moving under constant acceleration, constant velocity, that is 0 acceleration. So this is really a square root of T is taken outside from this, so T because positive, so this value has, and the average velocity is given 72 km per hour, and if it is converted into meter per second, then it will be 4 into actually 20. The 4, this, and this is the 20. Here is the 5, is the 25. Because finally calculated this value 25 is 15 seconds.